Here we are with 7-3, day 2. Still solving trig equations. Okay, remember our plan here is kind of each new lesson we kind of add a new little wrinkle to it. And today we are going to specifically look at trig equations that may take the form of a quadratic or have a quadratic term like cosine of 0. If you notice that's the case and it doesn't have a linear term, okay, that would be just like a cosine of theta, right? Like a trig function but no squared term. You would want to isolate your quadratic term and then take the square root. Now, of course, in the following slides, I will show you examples of what these would look like, right? Because I'll kind of lay out a couple different scenarios. There's really 3 here, but I think in the examples you only see the 2, right? 1 and 2. I don't think 3 comes up today. Big thing when you take a square root, remember the plus minus symbol. And once we have that set up, we're taking our inverse. Okay? Again, that's a scenario if you don't have a linear term. Okay? Now say you have both quadratic and a linear term. This would be something like this. Say you have 3 tangent squared theta minus 8 tan theta plus 5. Okay, that would have a quadratic term and a linear term. This is a little bit different. Here we'd have to set the equation equal to 0, and we need to factor. Notice how in scenario number 1, if we don't have that linear term, we don't need to factor. Okay? Once you have each one factored, set them equal to 0, and solve. This case could come up, but again, I don't think I worked it in today. If it's not factorable, you could always go to the quadratic formula. But again, I think we'll primarily focus on scenario 1 and 2. All right, so part A, right, really both of these. Well, here's that. So I'm looking at those 3 different scenarios that we had. What you're actually going to see today is basically scenario number 1. Okay, kind of like the first day, there's just a few too many examples. There's going to be a part 2 to 7-3 day 2. That case number 2 where you actually have to factor, that's not going to come up until the second day. So now that I peek ahead, scenario number 1 where we have a quadratic term and not a linear term, that's the only case we're looking at today. Okay? So that's right here. We're all set up that we just have our trig function squared. So we do a square root plus or minus square root 1 over square root 2. Okay? When I rationalize the bottom, I get plus or minus square root 2, which is starting to appear what I like to call unit circle friendly, right? Which makes me lean towards not going to end up using a calculator. I think I'm going to the unit circle. Both of these, just a heads up, give you solutions that are on the unit circle. Always be aware of that, but then also understand if you're in degrees, it kind of doesn't matter. You know, you could go to the calculator and you apply the rule correctly. You're going to get the same 2 answers the unit circle gave you. Radians is a bigger deal, and radians aren't going to come up today. If you want exact answers and they're on the unit circle, in radians, the best the calculator can do is give you a decimal approximation. So there you got to be you'd have to see it if we were in radians, okay? Here, not as big a deal. So after we take that square root, it really leaves us with two cases. One, we need to do inverse sine of square root 2 over 2. There we take a peek at our unit circle, and we see 45 degrees and 135. Those would be our solutions, okay? 45 and 135. However, this is really easy to forget in a case where you have to take a square root. We also have to do the inverse of negative square root 2 over 2, okay? That's what we did the plus minus when we took the square root. Get it on your paper right away so you remember that, okay, when I do a square root, I really have to do this inverse thing twice. I've got to take care of the positive case and the negative, because you'll see it's going to give you two different solutions, right? There it'd be a 225 and 315, okay? Okay. Let's take a look at tangent. Here I have a little bit of work ahead of time to do to get my trig function isolated. Three tan squared theta equals 1. Divided by 3, tan squared theta is a third. Let's do our square root. We got tangent of theta, right? So what that means when we get it to tangent of theta is we're all set up to do an inverse. We just got to clean up the right side a little bit, but everything we need to move has been moved because we just have a trig function over on the left side. Need to throw in my plus minus there. 1 over square root 3, there's our plus minus. Plus or minus square root 3 over 3, which again leads us to a scenario that's going to be on the unit circle, okay? First scenario we'd look at is inverse tangent of square root 3 over 3. Take a peek at the unit circle and see 30 degrees and 210. It's really kind of easy to forget about the negative case. Make sure not to do that. Okay, and again, I think the key is really right here. It almost got away from me. Really, right when you do the square root, you should get, with that square root, plus minus, right? So you see it as soon as you did the operation of a square root that you did the plus minus, and it's on your paper and you see it there. Hopefully that'll make you less likely to forget that negative case. Okay. Similar to that first one, 4 solutions instead of 2. That's pretty common, right? We're still seeing this theme that we usually get 2 solutions, right? But you have the positive case, and then you've got the negative case, right? So you see we're getting kind of 2 from each scenario, which leads to, obviously, 4 of them total. All right, again, notice these 2, right? They fit scenario number 1. We have a trig function squared, but we do not have a trig function to the first power, right? That's the scenario that I mentioned is going to come up tomorrow or in the next lesson. Okay, we'll call that part 2. Okay. going to subtract 3. And I get 4. Cosine squared equals negative 3. Okay. So I guess here's what I'd say. When you take the square root, whoops, forgot my theta. Here's where I think the plus minus should show up. Right down here that you say, all right, plus minus the square root of negative 3/4, which actually causes some problems, right? We can't take the square root of a negative, which means over on that right side, we can't get a number that it equals. But again, this will come up from time to time. Be ready for it. I keep throwing them in the notes just to show you that this can come up. It is possible that trig functions can have scenarios where they don't have solutions. Okay, this is one of them. 4 cosine squared theta plus 3 equals 0. There's not a number you can put in for theta that would make that equation true. Okay, not solvable. All right, part D will be the last one of the day, though, I gotta check. I think this one did have a typo. I can't remember if your notes got it right or not. Double check what you have right here. This plus needs to be a minus. If it wasn't, it's possible we were headed to the same scenario of no solutions, which is like, that's fine. We've seen that's possible, but we already saw that example on part C of no solutions, so it's like, don't want to do it again, but make sure that says a minus. Okay, the piece we're going to add here is we're headed back to the calculator. Okay, we're going to get, I think this will give us 4 solutions. But yeah, we're headed back to the calculator. So think of way back at the beginning, you had these 3 different trig functions, and they each had a rule to get the second answer. Maybe flip to those if you need to, right? Sine, cosine, tangent, each had a different one. Now I see the trig function is cosecant, so I'm eventually going to flip this and make it sine. Okay? So really the rule for getting your second answer that you're interested in is sine. Okay? But we've got a little work to do, right? For example, we need to add 3. Which would give us 2 cosecant squared divide by 2 cosecant squared theta equals 3 over 2. Okay. So we can go ahead and do our square root. Plus or minus square root 3 over square root 2. Okay, this is where I'm going to make the switch. Let's go sine. We've still got the plus minus, but now let's go square root 2 over square root 3. Now you saw in the other ones, I took the time to rationalize the bottom. If you're headed towards your calculator, there's really not a big need to do that. Right? It really wasn't a simplifying thing. I'm going to do it here just for fun to kind of make my point. Plus or minus square root 6 over 3, right? Really all that was about was to see, okay, is that sine value on the unit circle? That's why I was simplifying them before. You had the one with sine where I got square root 2 over 2, and then the one with tangent where I got square root 3 over 3, that's the reason I simplified it. If you can tell, and you got to be sure, right? But if you can tell, yeah, that's not going to end up being on the unit circle, you wouldn't have to rationalize a denominator. And you might have been able to see that right here. Maybe you couldn't. And it wasn't until here that you saw that, yeah, that's definitely, square root 2 over 2, square root 3 over 2. That's not one of those cases that's going to be on the unit circle. So here's the thing. Once we get to that point, that it's not on the unit circle, I'm going to make the switch. Okay. Square root 6 over 3 as a decimal point, 8165, right? We're going to the calculator, and we're going to have to do this as a decimal approximation at some point. I'm there, and I'm doing it, okay? So now I've got two scenarios to consider here. Inverse sine of 0.8165. Inverse sine of negative 0.8165, right? Your two cases, positive and negative, okay? Throw that in your calculator, making sure you're in degree mode, and you round to the nearest tenth, you're going to get 54.7, okay? That looks good. We'll call that solution number 1. This is what I was referring to a few minutes ago when I said you got to go check sine, right? In degrees, 180 minus your first answer will give you your second. $125.3 degrees. And there we go. Okay. We got the two solutions we're looking for. Okay. Not quite done because we still have to address the negative case, right? What we have on the right there, we throw into our calculator, negative 54.7. See a little pattern with the 54.7, but we put in the negative sign value, so it gave us a negative answer, that's fine. Remember this, we need to coterminal, right? We don't leave it like that. We'd add 360 to get our actual first answer, which would be 305.3. And that one we like. It's between 0 and 360, so we'll take it. Answer number 2. Okay. 180 minus our first answer, right? What do we, for the purposes of getting our second, what are we calling our first answer? What the calculator originally gave us. And I've heard some of you mention in class that you've noticed if we were to go with the 305, I guess technically we could. It just causes more problems that we do 180 minus 305. We go back to getting a negative answer, right? So yeah, it's possible you could use the 305, but why, right? If you remember to use the answer your calculator gave you, you can crunch the numbers right here and it will take you right to answer number 2, which I kind of like. I find that to kind of be the simplest thing is I just have to remember to go back and use that negative 54.7. Okay. Well, there it is. There was a little more to that one, right? And Not necessarily in the solving part of it, right? It still just led to the 4 solutions. There's more to write out because we did the calculator thing, but really that top half was we had to move around some other numbers like adding 3 and dividing by 2, and then we had to do the cosecant to sine switch. So that's a good example. It's got a lot of different elements that could come up when you're solving a trig function. Again, we'll need a part 2. Little bit of a heads up on that. We'll switch over to radians again for part 2, and that scenario of where we have to do some factoring. That's going to come up as well.